Let us now look at the empirical formula. So the empirical formula is the formula that shows the ratio of atoms found in the compound. It shows the number of atoms in their simple ratio. Let us now look at the steps to follow when finding the empirical formula. So Loma numero 1, we have identify the elements contained in the compound. Then Loma numero 2, identify the masses of elements contained in the compound. Loma numero 3, we have divide the mass of each element by its relative atomic mass. Loma numero 4, we have divide the answer by the smallest value. Then Loma numero 5, we have the answers are the ratio of elements and hence the empirical formula. And for us to identify and for us to understand the empirical formula, we are going to use some examples. So let us find the examples. So the first example, we have the compound has 50% sulfur and 50% oxygen. Determine the empirical formula. And the steps that I said, the first step, you need to identify the elements contained in the compound. So here we can identify that we have sulfur and oxygen. Then the second thing, identify the masses of elements contained in the compound. So sulfur have been given 50% and oxygen have been given 50. So sulfur we're going to write 50 and oxygen we're going to write 50. Then our third step reads, divide the mass of each element by its relative atomic mass. So we are going to identify the relative atomic mass of sulfur and oxygen. And we know that sulfur, the relative atomic mass is 32 and that of oxygen is 16. So we'll say 50 divided by 32 and we're going to say 50 divided by 16. Then we are going to find our answers. Then Loma numero 4 reads, divide the answers by the smallest value. So the answers that we're going to find, we're going to divide them by the smallest value. Then the last step reads, the answer are the ratio of elements and hence the empirical formula. So let us find the empirical formula of the first question. So it reads, the compound has 50% sulfur and 50% oxygen. Determine the empirical formula. So the first thing is to identify the elements. So we have two elements there. We have sulfur. We also have oxygen. Then we have been told that sulfur there is 50%. So we'll say 50% sulfur and oxygen we have been told it's 50%. So here we can say that our mass is 50 for sulfur and for oxygen it's 50. Then from there we're going to divide the masses by the relative atomic mass. So the relative atomic mass of sulfur is 32, then that of oxygen is 16. So 50 divided by 32, we're going to have 1.56. So we're going to have 1.56. Then 50 divided by 16, we're going to have 3.125. Then the next step says that the answers that we're going to find, you're going to divide them by the smallest number. So the smallest number there, we have 1.56. So we'll say 1.56 divided by 1.56. Then we'll say 3.125 divided by 1.56. So we'll say divide by 1.56. So we're going to have sulfur there and oxygen. So when we find our answers there, for sulfur we're going to have 1. Then for oxygen we're going to have 2.0025. So as this is our ratio. So we can say 1 to 2. That's our ratio, and our empirical formula is going to have SO2. since sulfur there it's 1 and oxygen it's 2, so we're going to say 1 2 2, hence the empirical formula is SO2. So that's going to be our answer. Let us look at question 2. An experiment shows that 32 grams of sulfur combines with 32 grams of oxygen to form the compound sulfur dioxide. What is the empirical formula? So the first thing that we're supposed to do is to identify the element. So we have sulfur there, then we also have oxygen. So we're going to say we have our sulfur there, then we also have our oxygen. That's the first thing that we're going to do. Then the second thing that we're supposed to do is to find the masses. So we've been told 32 grams of sulfur there, then we also have 32 grams of oxygen. So we'll say 32 grams of sulfur, then we'll say 32 grams of oxygen. Then after that we're going to divide these we're going to divide the masses by the relative atomic mass. So divide by the relative atomic mass of sulfur is 32, so we're going to have 32 there. Then the relative atomic mass of oxygen is 16. So 32 divided by 32, we're going to have 1 there, 2. 32 divided by 16, we're going to have 2. So the ratio there, we're going to have 1 2 2. So sulfur there it's 1 and oxygen it's 2. So to write the empirical formula is going to be SO2. So here we can say 1 2 2, hence the empirical formula is SO2. So that's going to be our answer. So question 3 reads, a compound of magnesium and chlorine is found to contain 25.3% of magnesium by mass. Calculate the empirical formula for the compound. So the first thing that you need to do is to identify the elements. So we have been given magnesium there and chlorine. So we're going to write down the elements. So we have magnesium, then we also have chlorine. Then the second thing that we need to do is to identify their masses. So we have been told that we have 25.3% of magnesium. So magnesium we have been given as 25.3%. So finding that of chlorine, we're going to say 100 minus 25.3, and we're going to have 74.7%. And since we have our percentage mass there, we can say we're going to have 25.3 for magnesium, and chlorine, the mass, we're going to have 74.7. And the next thing that we're going to do, we're going to divide this by the relative atomic mass of magnesium, which is 24. Then the relative atomic mass of chlorine, that's 35.5. So 25.3 divided by 24, that's 1.1. Then 74.7 divided by 35.5, that's 2.1. 1. So we're going to write down magnesium and choline there. So magnesium, we know that's 1.1. Then choline, we know that's 2.1. Then since these are our answers, we're going to divide by the smallest number. So the smallest number there is 1.1. So divide by 1.1. So there we're going to have 1, 2, 2.1 divided by 1.1, we're going to have 2. So the ratio, we have 1 to 2. So we can say, hence the empirical formula is, so magnesium, we know that's 1, and chlorine, that's 2. So our empirical formula, we're going to have magnesium, which is 1, then chlorine, which is 2. So that's going to be our answer. Question 4 reads, in an analysis of black copper oxide, the percentage of copper was found to be 79%. What is the percent of oxygen, and hence find the empirical formula of this compound? So we are required to calculate the percentage of oxygen. So we can say X%, which is that of oxygen, plus that of copper, which we have been given as 79%. So plus 79% is equal to 100%. So we can say our X% is equal to 100% minus 79%. So our X%, which is that of oxygen, 100 minus 79, we're going to have 21%. So we can say oxygen there, oxygen is 21%. And since we have calculated the percent of oxygen, we can now write down the empirical formula. So the first thing is to identify the elements, and we have 2 elements. We have copper and we also have oxygen. So we have our copper there, then we have our oxygen. Then copper, we have been given in the question as 79%. So 79% to oxygen. Oxygen we have calculated as 21%. So we know that this is going to be 79 as the mass, then we're going to have 21 as the mass. Then we are going to divide this by the relative atomic mass of copper, and the relative atomic mass for copper is 64. Then the relative atomic mass of oxygen is 16.